Hello everyone, I just wanted to post this real quick video to go over the easiest possible method to answer any stoichiometry question. A few of my students are having a little bit of difficulty with stoichiometry, and that's to be expected. This is one of the harder concepts to learn in high school science or in high school chemistry. But I promise, once you understand this, it's going to get much, much easier. So, let's start with a practice question. Heating potassium chlorate is a fairly common and inexpensive way of obtaining oxygen gas in school labs. This is the decomposition reaction here, and we're producing oxygen gas. The question here asks for moles of oxygen gas that's going to theoretically be produced from heating 735.3 grams of the potassium chlorate. And we also have the molar mass of potassium chlorate, which is 122.55. So the first thing I do is I write out the chemical equation. I know it's a little annoying to rewrite the equation, but I promise you it's very, very important. The second thing I do is I put lines between the chemicals, just like so. And the reason I do that is because only moles can pass through these borders, okay? Nothing else, the weight in grams, cannot pass through, or the weight, the volume, or the concentration, anything cannot pass through. It's only moles that can be compared from one to the other. And now I write my givens under each set. So first, my given here for potassium chlorate is that I have a mass that's equal to 735.3 grams, right? I also have a molar mass that is equal to 122.55 grams per mole, right? And what I want to find is the number of moles of oxygen. But the only thing that can pass through from the potassium chlorate to the oxygen is moles. So I have to first convert the potassium chlorate to moles. And the way I do that is N for the number of moles equals the mass divided by the molar mass. And so what we get is 735.3 divided by 122.55. And once I shift everything up a little bit, I'm going to add my answer here. 122.55. What I get is N equals 6 moles. And now that I have moles, I know this can cross this border here, right? And so now I have N of O2 is going to be related to, so there's going to be some relationship to N of KClO3, right? But it depends on what that relationship is. And the way I do this relationship is I see there's a 3 in front of the oxygen, and there's a 2 in front of the potassium chlorate. And so that means that I'm going to multiply my answer by 3 and divide it by 2. Why? Because there's 3 oxygens for every 2 potassium chlorates. That means there's going to be more oxygen than potassium chlorate. So then I do NO2 equals 3 over 2 times NKClO3. I multiply by what's in front of what I'm finding, and I divide by what answer I am trying to move the moles to. And so that becomes NO2 equals 3 over 2 times 6. NO2 equals, well, 3 times 6 is 18, divided by 2 is 9 moles. So the answer here is, therefore, 9 moles of O2 gas is produced.